Hi guys, welcome to my channel, The Analyst. Today we'll have a look at decision trees. The data set that we will be using is the US crime data set. It has around 16 variables and 47 observations. Our target variable is crime. As you can see, the output is continuous. So we'll use the decision tree for regression. Moving on to the demo, I clear my environment and I load the tree library. I set my seed to 123. This is so that I can replicate the output. Then I read in the data, the US crime data, and I use the head function to see the first 6 rows. Here's my data, and we have the crime variable, which is basically our target variable. I use the tree function to fit a tree model, a decision tree, and I predict crime. Okay, I fed in the crime data. Take the summary of the tree model, and what we see over here is that the model has used only 4 variables for the purpose of prediction out of 15. One variable over here basically is the target. Okay, out of 15, like it's used only 4. These are the main ones that it's used. Also, there are 7 leaves, 7 terminal nodes, and we have a residual mean deviance of 47,390. This should be as low as possible. Now let's plot the model that we have, and this is what we get. Okay, the variables that are of utmost importance are PO1, POP, NW, and so on. That was basically specified over here. Alright, this is basically the structure of a regression tree. Now depending on whenever we have a new data, right, first it will check whether P01 is less than 7.6. If it is yes, it will move into this branch. If P is less than 22.5, then it will move over here, and so on. Okay, just a tree structure. Next, what we'll do is that we'll find the R-square value. So how well basically this model is. Now I know we've not broken down our data into test and train, but that's alright because we anyway have very little observations. What we'll do is that the same data that we use to train the model, we'll use the same data to test it also. So I do a prediction over here. I feed in the crime data, and from this I calculate the R-square. Now the R-square formula is 1 minus sum of squared errors divided by sum of squared total. Now the sum of squared errors is calculated by the sum of basically whatever your predicted value minus what the original data was. Like we already know what the target variables are, right? The target outputs are already over here. So we'll do that, whatever the predicted minus that, we'll take the square of it and we'll sum it. Similarly, sum of totals. This is basically the formula for sum of totals. We plug both these values inside over here to get the R-square of the tree. We get around 0.72. So the tree accounts for 72% of the variance, which is pretty good. Okay. Now let's see if by whether pruning, by removing certain nodes, we are able to improve the R-square value. So what I do is that we currently have 7 terminal nodes. We'll try and reduce the number of nodes and check if we get a better tree. So that's what I did. I did a prune.tree, fed the model, and based on size being 7654321, and then I plotted the deviation. Okay, the deviance. As you can see, the deviance keeps on increasing as we reduce the number of nodes. This is not a good thing. So what the model used and the number of nodes that it came out with by default, that's basically the optimal one in this case. Now, if we want to see that for a given node, okay, what exactly, which all records fall into that given node, then all we have to do is str, where we check the structure of basically the tree model object, and we use where. Yep. So what we did is that we have which tree model where equal to 1. So basically in the first node, what all records are there. So in leaf 1, we basically have all these records, record 3, 17, 22, 27, 31, 42 and 45. Similarly, we can do for the rest, for all the 7 permanent nodes. Just replace the value 1 to 7 over here, whatever you want, to check which all records fall in which node. Alright guys, that's it for this video. If you liked it, please like and subscribe. Thank you so much.